In this video, we are going to discuss how to find the principal strains and planes when a strain matrix is given. In previous videos, we have discussed principal stresses and principal planes. Do check that video so that this principal strains and planes will be much easier. I'll provide the link in description box. In general, a strain matrix is represented by epsilon xx, gamma xy, gamma xz, gamma xy, epsilon yy, gamma yz, gamma xz, gamma yz, and epsilon zz. So the equations we are going to use to solve the present principal strains and principal planes are epsilon cube minus j1 epsilon square plus j2 epsilon minus j3 equal to 0, where j1, j2 and j3 are first, second and third strain invariants. j1 equal to epsilon xx plus epsilon yy plus epsilon zz, which is nothing but the summation of diagonal elements in the given strain matrix. J2 is the summation of determinants of 2 by 2 matrices. So first 2 by 2 matrix is epsilon xx, epsilon yy, exy and exy. Here we'll follow a notation where exy is nothing but half of gamma xy. Plus, coming to second 2 by 2 matrix, it is epsilon yy, epsilon zz, eyz and eyz, plus the third 2 by 2 matrix, which is the remaining terms, that is determinant of epsilon xx, epsilon zz, exz, exz and exz, and third invariant j3 is the determinant of epsilon xx, exy, exz, exy, epsilon yy, eyz, exz, eyz and epsilon zz. J3 is nothing but the determinant of given strain matrix replaced with exy terms instead of gamma xy terms, where exy is half of gamma xy and eyz is half of gamma yz and exz is half of gamma xz. To determine the principal planes, we make use of three equations, which are epsilon xx minus epsilon into nx plus exy into ny plus exz into nz equal to 0. Coming to second equation, that is exy into nx plus epsilon yy minus epsilon into ny plus eyz into nz equal to 0. And third equation, exz into nx plus eyz into ny plus epsilon zz minus epsilon into nz equal to 0, where epsilon is principal strain and nx, ny, nz are direction cosines. Now we'll solve a numerical where the strain matrix is given as 1 0 0 and 0 0 minus 4 and 0 minus 4 3 into P, where P equal to 10 to the power of minus 4. So for this given strain matrix, we have to find the principal strains and principal planes. First we have to find J1, J2 and J3. J1 is epsilon xx plus epsilon yy plus epsilon zz, that is 1 plus 3 4p. And coming to J2, it is determinant of one 0 0 0 plus the second 2 by 2 matrix 0 3 and half of minus 4, because it is epsilon yz, which is half of gamma yz. So minus 2 and minus 2 plus and determinant of 1 3 half of 0 and half of 0. Determinant of 1 3 0 and 0, which is equal to 0 minus 4 plus 3. Here the matrix P is mentioned, so this being 2 by 2 matrix, we get P square, which is equal to minus P square. Now coming to J3, which is determinant of P into the diagonal elements remain same and gamma terms we take half. So 1 0 3 and half of 0 0 0 minus 4 and 0 minus 4. So that comes 0 0 minus 2 and 0 minus 2. So this becomes P into determinant of 1 into 0 into 3 minus of minus 2 into minus 2. So that comes minus 4p square and plus 0 into and plus 0. So remaining terms are 0 and the J3 we obtain will be minus 4p cube. So when you substitute the J1, J2, J3 in above equation, so that becomes epsilon cube minus J1 I am taking as 4. So P will take that later. So epsilon cube minus 4 epsilon square plus J2, that is minus 1 So this becomes minus 1 into epsilon and minus J3. So that becomes minus of minus 4. So that is plus 4 equal to 0. So P will substitute in the last. So the entire equation has turned to epsilon cube minus 4 epsilon square minus epsilon plus 4 equal to 0. So when you solve this third degree equation in Calc, we get epsilon as 1 minus 1 and 4. So these are the principal strains for the given strain matrix. So here we have left the P, so the epsilon roots will be minus P, P and 4P. So the least principal strain is called minor principal strain and highest principal strain is called major principal strain, and the intermediate one, that is P here, is called intermediate principal strain. Now we will find the principal planes for the obtained principal strains. I am considering principal strains as 1, minus 1 and 4 for my convenience. So substituting the values in the equations, here other than diagonal terms we will take half of the terms that I have mentioned. For epsilon equal to 1, my first equation turns to be, so here epsilon x minus epsilon, that is 1 minus 1 into nx and plus 0 into ny, and so that is 0 plus 0 into nz, that is also 0. My entire equation has become 0. Coming to second equation, so exy and eyz terms have to take half, so 0 and minus 4 half is minus 2, so minus 2 nz, and coming to the epsilon yy minus epsilon, that is 0 minus 1, that is minus ny equal to 0. So from here I have obtained ny equal to minus 2nz. So coming to third equation, exz and eyz, these terms I am supposed to take half. So first exz is 0, so half of minus 4 is minus 2 into ny, and epsilon zz minus epsilon, it is 3 minus 1, so that becomes 2nz equal to 0. So from here ny equal to nz. So from these two equations A and B, these two equations satisfy only when ny equal to nz equal to 0. So from relation nx square plus ny square plus nz square equal to 1, the ny nz are 0, so that means nx square equal to 1, which means nx equal to 1. So for principal strain epsilon equal to P, the principal directions are nx equal to 1 and ny equal to nz equal to 0. Coming to second principal strain, that is epsilon equal to minus 1, my first equation becomes 1 minus of minus 1, 2nx equal to 0, which means nx equal to 0, and my second equation exy is 0 and epsilon yy minus epsilon into ny, which is 0 minus of minus 1, that is plus 1 into ny, and eyz is half of minus 4, that is minus 2 into nz equal to 0, which means ny equal to 2nz. And coming to third equation, exz is 0 and eyz, that is minus 4 half, that is minus 2 ny, plus ezz is 3 minus of minus 1, that becomes 4 nz equal to 0. So which means the obtained two equations are similar, and from relation nx square plus ny square plus nz square equal to 1, we get nx is 0, which means ny square, that is 2nz whole square, plus nz square equal to 1, which means nz equal to 1 by root 5, and ny equal to 2nz, that is 2 into 1 by root 5, that is 2 by root 5. So nz equal to 1 by root 5, which is equal to 0.447, and ny equal to 2 by root 5, that is 0.894. So for principal strain epsilon equal to minus p, nx equal to 0, ny equal to 0.894, and nz equal to 0.447. Coming to third principal strain, that is epsilon equal to 4. These are the equations for finding principal planes. So the first equation, which is epsilon xx minus epsilon, that is 1 minus 4 minus 3nx equal to 0, as gamma xy and gamma xz are 0. So from this equation nx equal to 0. Coming to second equation, exy is 0, that is 0 plus eyy is 0, 0 minus of 4, so that becomes minus 4ny plus eyz, that is half of minus 4, that is minus 2nz equal to 0. So from this nz equal to minus 2ny. From relation nx square plus ny square plus nz square equal to 1, we get nx as 0, so ny square plus nz square, that is minus 2ny whole square, that is 4ny square equal to 1. So ny equal to 1 by root 5, which is equal to 0.447, and nz equal to minus 2ny, that is minus 2 by root 5, that is minus 0.894. For the principal strain epsilon equal to 4p, the principal directions are nx equal to 0, ny equal to 0.447 and nz equal to minus 0.894. So in this way we can find the principal strains and their principal directions for the given strain matrix.